So school's been out for a week now, and I'm feeling the calling to teach some more math. So I think we'll do some geometry, but before we get into the math, I just got to give a shout out to the algebros. I hope you're keeping it real, having a good summer thus far, enjoying the weather, and maybe even doing some math. That would be awesome. Okay, so what we're going to do for this tutorial is develop a method for finding the area of any regular polygon. So area is a huge theme of geometry, and we're going to find the area of any regular polygon. So a regular polygon is any polygon that is equilateral and equiangular. So to sort of demonstrate the method, let's just think about a regular hexagon. I'm no artist, but a regular hexagon is 6 sides, and each side is congruent, and each of these interior angles is congruent. So this method of finding the area of any regular polygon has to do with sort of finding the center of that polygon and then thinking about all of these triangles, all these triangles that construct the polygon. So in the case of a hexagon, there are 6 of those triangles because there are 6 sides. For an octagon, there would be 8 of those triangles. You know, for a pentagon, there'd be 5 of those triangles. So what we're really trying to do is sort of take the number of triangles and then multiply take the area of one of those triangles and then multiply it by the number of triangles there are. Okay, so I guess one more example. If you think about an equilateral triangle, this is a equilateral triangle that is regular. It's got a center, and then these 3 triangles are the 3 congruent triangles that we'll be thinking of. We'll find the area of one of those, multiply it by 3. Just like for the hexagon, we find the area of one of those, multiply it by 6. For an octagon, we'd find the area of one of those triangles, multiply it by 8. Okay. So let's go back to thinking about a hexagon. Okay. So this segment right there, the segment that goes from the center of the hexagon to one of the vertices, that's called a radius. And if you look at any 2 consecutive radii, then you get this angle right here, which is called the central angle of the polygon. When you look at the height of this triangle, so that this triangle has a base here, we'll call that B for base. It's got this height right here. That's the height of the triangle. And that has a name. That's called the apothem. It's really fun to say because it sounds like you're saying a possum, only with a speech impediment. It's an apothem. So this is the apothem. And it happens to be the height of one of the 6, congruent triangles. So if we can take the area of this triangle, which would be 1/2 times B times A, and then multiply it by 6, we would have the area of the hexagon. So in this case, the area of the hexagon is going to be 1/2 times B times, I'll call it A for apothem, times 6, because there are 6 of these triangles. This is 1/2 base times height, and then times 6 because there are 6 of them. Okay. So now what we do is we think about the general case. In the general case, we're thinking about a regular n-gon. And for regular n-gon, there are n of these triangles. And so the area formula sort of generalizes to 1/2 A N S. That's the way I remember it. Where A is the apothem, N is the number of sides, and S is the side length. So where does that fit into here? Well, A is the apothem, N is the number of sides, 6 in this case, and S is the side length, which happens to be the base of the triangle. So the side length of this hexagon is the base of one of those triangles. So area equals 1/2 ANS gives the area of any regular polygon. So let's put that to use. So here's an example. How about find the area of a regular octagon of side length 4. And 4 whatever meters, I guess. 4 meters. Okay. So I don't actually draw the octagon. What I draw is just one of the triangles, one of the 8 triangles that make up that octagon. So I start with my area formula. Area equals 1/2 ANS. And then I plug in everything that I know. Do I know A? Well, no, I don't. Do I know N? Well, it's an octagon, and octagons have 8 sides, and so N is 8. And do I know S? Yes, I know S is 4. So the only thing I have left to find is the length of the apothem. And I can do that fairly easily by thinking of just one of those 8 triangles that make up this octagon. So I just draw one of those 8 triangles. And I know that the side length is 4. This is 4. So when I drop the apothem is here. Hi, Fozzie. So the apothem is here. I'll call it A. And now this is 2. And so if I can find this angle measure, then I'll be able to find A. So we first find the central angle, which is the angle between any 2 radii, which is here, which is 360 divided by 8, because there are 8 of these 8 of these triangles. Right, so 360 divided by 8 is 45. And so if I take 45 and cut that in half, I have 22.5. So the measure of this angle here is 22.5 degrees. And so now I can find A. I can say that the tangent of 22.5 is equal to 2 over A. Multiply both sides by A, divide both sides by tangent 22.5 to find A is equal to 2 divided by the tangent of 22.5. And so A is 2 divided by the tangent of 22.5. And so the area of a regular octagon with side length of 4, the area is equal to 1/2 times 2 over the tangent of 22.5 times 8 times 4. Whatever that is. That's it. Okay, so let's do another example. How about find the area of a regular hexagon with radius of let's say radius of 4 meters. Sure. So once again, we have that area is equal to 1/2 ANS because it's a regular hexagon. And so, do we know A? No. Do we know N? Yes, it's 6 because it's a hexagon. And do we know S? Well, no. So let's draw our triangle, one of 6 triangles. And we know that the radius is 4, and so this is 4, and this is 4. Where this is the central angle of the hexagon. So to find the central angle of the hexagon, we take 360 and divide it by 6. Well, 360 divided by 6 is 60. And since this is isosceles, so those two angles are congruent. And so those two angles are both 60 as well. This is an equilateral triangle. The side length is 4. So we can say that the side length is 4. That's the nice thing about hexagons, is that a hexagon is really broken. Its pieces are 6 equilateral triangles, which is nice. So if we cut this triangle with the apothem there, now this is, now that's 2, right? So let's think about this triangle right here. This was a 60-degree angle. We cut it in half. That's 30. That's 90, and that's 60. This is a 60. This is a 30, 60, 90. And so if this is 2, then A is 2 root 3. So A is 2 roots of 3. Right? Because this is a 30, 60, 90. And so the area of this regular hexagon is 1/2 times 2 root 3 times 6 times 4. 1/2 and the 2 cancel. This is 24 root 3 meters squared. Right? So it's area, so it's units squared. So the nice thing about equilateral triangles and hexagons is that when you make these triangles with the apothem, you get a 30, 60, 90. If you have a square, which is a regular polygon, you end up with a 45, 45, 90. For all other regular polygons, to find the area, you're going to have to use trigonometric ratios using the central angle. Okay, so I hope this helps you find the area of regular polygons. Any questions? Send them my way.